For a school fundraiser, hot dogs and hamburgers are sold. Each hot dog sold results in a $2 profit, while each hamburger results in a $3 profit. The group hopes to raise more than $600, but only has 200 hot dogs and 150 hamburgers. Create and solve a system of inequalities to show graphically how many of each can be sold to achieve the goal. Here we have to use the information provided to develop a system of inequalities. We'll introduce variables to represent the number of hot dogs sold and the number of hamburgers sold. We then develop a system of inequalities using these variables to represent the situation. And then we'll graph that resulting system of inequalities. Here I'll let X represent the number of hot dogs sold and Y represent the number of hamburgers sold. Since each hot dog results in a $2 profit and each hamburger results in a $3 profit, we can come up with the inequality 2x plus 3y is greater than 600, noting that the group wants to raise more than $600. We also have the inequality x, the number of hot dogs sold, is less than or equal to 200 because there are only 200 hot dogs available. And y, the number of hamburgers, must be less than or equal to 150. In order to graph these, I will use 20 corresponding to each square on the grid provided. To graph the first boundary line, 2x plus 3y equals 600, I'll plot the x and y intercepts. For the x-intercept, we make y equals 0, giving 2x equals 600, corresponding to an x-intercept of 300. For the y-intercept, we plug in x equals 0. This gives 3y equals 600, or y equals 200. We then have to plot the other inequality boundary lines. For x less than or equal to 200, we would plot the line x equals 200. Note in this case, it's going to be a solid line, whereas the previous boundary line was dashed because it corresponded only to a greater than symbol. We then plot the boundary line for y less than or equal to 150. This will be a horizontal solid line at a y value of 150. We then have to shade in the corresponding region. In this case, this will be the triangular region in between the three boundary lines.